Hello champions, welcome to Deeksha Karnataka YouTube channel. Now today in Masterstroke series I am going to discuss electromagnetic induction and EM waves. So two chapters combined in one video back to back, and if you can study these two chapters, you can expect 3 to 4 questions in total. EMI, that is electromagnetic induction, from this chapter you can expect about 2 to 3 questions. EM waves 1 question, so total 3, maximum 4 questions you can get from these two chapters. And so today, after going through this lecture, if you still have any doubts, any concern, you can mention that in the comment below. Also you can ask me during my live session. Live sessions are scheduled in our channel, so if you are not yet subscribed to our channel, don't forget to subscribe and also join the WhatsApp channel, so that whenever I am live and all the teachers are live, you will get the notification that the live class starts. Okay, so there you can come and ask all of your queries, all of your questions there. Now let's start. As usual, first you will see what are all the concepts that we are going to discuss. So we are discussing electromagnetic induction, magnetic flux, Faraday's law and Lenz's law, motional electromotive force, that is motional EMF, inductance and AC generator. So let's start with electromagnetic induction. So what is in induction basically? Suppose you have a magnet. You have a magnet. Magnet is very common to have, right? And you have a coil. Coil means a wire. Okay, you have made some connection like this, and then you have connected it across a galvanometer. Okay, now if you move the magnet through this coil, okay, if you move towards and away from this coil, what you will observe that galvanometer is deflecting. Deflection of a galvanometer means charge is flowing in the circuit, and flow of charge means what? Flow of charge means there is a current, and current means what? Current means there has to be a source of current, and source of current generally is a battery, and in common terms we call it electromotive force, right? So electromotive force is the force that requires to move a electron in a circuit. Okay, so that is the common term for the force that is required to move an electron inside a circuit. So basically what is happening is that by moving the magnet, you are producing an electromotive force. Remember, you are not touching the circuit directly, you are not doing anything. Only thing you are doing, you are moving the magnet towards and away from this coil. And here that experimental setup is demonstrated. Here you have a magnet which you are bringing towards the coil, and then you are moving it away from the coil, and by doing so the galvanometer is deflecting. If the magnet is static, you are not observing anything. Okay, and if the magnet is moving towards the coil, if you see the deflection in certain direction. When the magnet is moving away from the coil, you are observing the deflection in the opposite side. Okay, so electric current can be induced. This current is called induced current. Okay, because normally if you leave the circuit as it is, there will be no current, right? So for example, if I don't ask you to study, you will not study, you will just sleep and you will wander, right? No, you study. Very good. Anyway, so electric currents can be induced in closed circuit when subjected to changing magnetic field. So magnet is not important. What is important is the changing magnetic field. So magnet have magnetic field lines. Okay, from north pole it goes out and it comes back towards the south pole, right? You all know. And inside the magnet it goes from south to north. So basically what does it mean? That if you can change the magnetic field lines linked with the coil, okay, suppose initially number of lines linked are 10, and if you are, as you are moving closer, more number of field lines are getting attached with the coil, so field lines are increasing. And by changing the magnetic field lines means either you are increasing it or you are decreasing it. Both way induction is possible. The phenomenon in which electric current is generated by varying magnetic field is called electromagnetic induction. So induction is basically induced current, and it is because of the motion of magnet. It is called electro means the current, and magnet means obviously the magnet. So electromagnetic induction comes from the fact that it is basically the motion of magnet is producing electric current, and that's why the term is electromagnetic induction obviously inducing. Now if you are using a induction oven at your home, basically that also works on the same principle. Only thing is that there heat is induced, not current. Okay, so heat basically is being induced in a induction oven, but the concept is same. Again, you are not directly touching the induction coil which is inside the ceramic shield. I hope all of you have seen induction oven. If you have not, maybe you can search on Google, see how does an induction oven looks like, right? Let's move on. Let's look into the another important concept called magnetic flux. Magnetic flux is same as electric flux. Electric flux was what? Electric flux is the number of field lines linked with the surface. Similarly, magnetic field lines linked with the surface is called magnetic flux. And in case where magnetic field and the surface are at different angle, if the angle is at an angle theta, then magnetic flux is given by BA cos theta, basically B dot A. So it is BA cos theta. Okay, SI unit of magnetic flux is Weber. SI unit of magnetic flux is Weber or Tesla meter square. Remember these units. Based on these units, we have seen a lot of questions, MCQ questions, not only your PUC model paper PUC exams, but also in KCET exam. Okay, the unit of magnetic flux is, so it will be either Weber or Tesla meter square, not Tesla per meter square. Okay, let's move on. Faraday's law of induction. So whenever we see some thing to happen, the corresponding law has to be there as well. Okay, for example, if I push something, it moves. So from there, Newton's law of motion came into effect. Okay, similarly, we move a magnet, we see some motion of current. That means corresponding law has to be there, which will determine how much current it will flow if the magnetic flux changes something. Okay, so based on observation, based on some calculations, the laws are basically generalized. So once the law is established, it will be applicable to all cases. That's why it is called a law. An EMF is induced in a coil. EMF means electromotive force. An EMF is induced in a coil when magnetic flux through the coil changes with time. So very important. So if you change the magnetic flux linked with the coil, then there will be an induced EMF. The magnitude of the induced EMF in a circuit is equal to the time rate of change of magnetic flux through the circuit. Okay, so if this is the induced EMF, this is induced EMF, and this is the rate of change of flux. So they are actually exactly equal. The negative sign we will explain in a while. In case of closely wounded coil of n number of turns, so this is for one loop, this is for n number of loops. So more than one coils are one after another. So number of turns is here is 1, here number of turns is only 1. Okay, so change of flux associated with each turn is n phi. So total flux linked with b n into d phi b by dt. Obviously n is a constant, so n will be outside the differentiation. So epsilon equals to minus n d phi by dt. Most cases, if they ask you about magnitude, you can ignore the negative sign. Magnitude, mean value, average value, in those cases negative sign you can ignore. Okay, now let's see one question. A magnetic field of flux density 1 Weber per meter square. Flux density means, so what is flux density? Flux density is flux divided by area is called flux density. Okay, a magnetic field of flux density 1 Weber per meter square acts normal to an 80 turn coil of 0.01 meter square area. Okay, if this coil is removed from the field in 0.2 second, the EMF induced in it. First of all, we have to calculate the flux. So flux is flux density into area. Okay, so flux density here given is 1 Weber per meter square and area is given 0.01 meter square. So it will be 10 to the power of minus 2 Weber. This is the flux. Now what is the induced EMF? Induced EMF is, so they asked you the magnitude, they have all the values are positive, so negative sign is not required. Because you are removing it, it will be negative of negative, so it will be positive. So I'm not going into that detail. So remember that most cases, 99.9 cases, you can simply ignore the negative sign, just calculate the change in flux and then in time. Okay, so when the entire coil was inside the magnetic field, the flux was this much. Now when you removed it completely, the flux is now 0. The flux is now 0. So what is the change in flux? Change in flux, or d phi, will be equals to phi. Okay, because phi minus 0. So phi minus 0 is the change in flux. So d phi will be equals to phi. Now what is induced EMF? Induced EMF is N d phi by dt. Right? D phi by dt. Now dt here is given 0.2 second. Right? N is given 80 turns. And d phi is, initially it was 10 to the power of minus 2, final was 0. So change in flux is itself the flux, that is 10 to the power of minus 2, and dt is 0.2. 0.2 means 2 into 10 to the power of minus 1. So you can multiply, you get 40 and you get 4 volt. So the induced EMF here is 4 volt. Correct answer is option B. So this type of questions are common in KCET, and if you want to practice more such questions for your KCET preparation, ABHYAS KCET 2020 test series is here. Here you will get 35 KCET tests. Out of them 4 are free and 31 are paid. So if you want to access free tests or paid test, first of all you have to register yourself. The link of the registration is given in the description section of this video. Go there, check the website, register yourself for the free tests. So once you get access to the free test, you can only access them through our app or our website. You will not get the question paper in a downloadable format in your email box. So don't think that okay, I am not receiving the mail, that means I will not get the question paper. You have to access the questions and the free tests as well as paid tests all through our app or our website. Okay, it is not available to download. Now here what you will get the question paper first of all. Also you will get the question paper in the form of a test. So basically you have to take the test, 60 questions in 60 minutes. So that is very, very important. And only getting the question paper is not sufficient. There are many people, they give you a simple question paper. Books also give you question paper. But whether you are able to solve them 60 questions in 60 minutes with a proper time management is very, very essential. And our toppers have done that and they did an excellent job last year. So you may be one of them in next year, right? Already more than 1,000 students have subscribed for this, and in this year what we have included, without increasing the price, we are giving you chapter wise 10 years KCET PYQ in a form of test or quiz, absolutely free of cost. Okay, so you will get chapter wise KCET PYQs absolutely free of cost. Here you will get 10 years PYQs in the form of quiz. So again you can check it if you are able to solve all and every questions properly or not. And also the coverage is physics, chemistry, maths as well as biology is also given as a content, and entire price as same as last year, that is 1499. Without increasing any cost, we are giving you extra free content. Right, now let's move on with our lecture. Now Faraday's law is done. Faraday's law gives you the magnitude of the EMF. Faraday's law gives you the magnitude of the EMF. Now Lenz's law gives you the polarity of the EMF. So the polarity of induced EMF is such that it tends to produce a current which opposes the change in the magnetic flux that produces it. This is the consequence of conservation of energy. Let us understand. So the negative sign that is coming, the negative sign says that the induced EMF will produce a current that will oppose the cause, which is very important to understand. So first of all, let us understand this concept. Many students falters in Lenz's law. So when you are taking a north pole of a magnet towards a coil, there is a current produced in the coil. Now coil being a coil also produces its own magnetic field. A current carrying coil behaves like a magnetic dipole, right? We have studied that in IA. So this coil will also produce a magnetic field because of the induced current as well. So no matter what type of current, if there is a current in a coil, it will produce a magnetic field. Now this magnetic field will oppose the original magnetic field. So if you consider this circuit where a north pole is being moved towards the coil, the near end of the coil which is facing the north pole will produce a north pole itself, so that this north pole and this north pole, they repel each other. Now how to find the direction of current? So if you draw an N-like structure and if you curve both sides, this means if the current is flowing in this direction, that is clockwise direction, you get north pole, and if you are getting a current like this S-like structure, and if the current is flowing in the anti-clockwise direction, you get a south pole. Okay, so when the north pole is approaching the coil, a north pole will be produced, so these two will repel each other. Similarly, when the north pole is moving away from the coil, a south pole will produce, and this south pole will try to stop the motion. So both way it is like a two-way jam. One way it is trying to stop, and another way it is trying to attract. Okay, so both is possible. Right, now one important part is that what would have happened if when we are bringing the north pole, suppose a south pole is produced. Why it will violate the conservation of energy? Let us understand that. So we know that energy cannot be produced out of nothing. So if you take this north pole and if you bring it towards the this coil, then what would have happened? So this is north pole, this is south pole. Suppose, imagine. So what will happen? North pole and south pole will attract each other. So you push it for say 1 second or 2 seconds. South pole is produced. Now you do not need to push it anymore. The north pole will automatically keep on moving towards the coil, and then when it is going on the other side, then there will be a same pole produced, so it will start attracting it. So infinite loop will create, and you will get infinite amount of energy, current energy, which is obviously not possible. So because of the, you just do a work for 1 second and the coil will start producing current for eternity of infinite time, which is obviously not possible. So without doing any work, you will not be able to produce energy. So without studying, you will not be able to get a good score in KCET. Okay, if you think that okay, I will do some random markings and I will score a rank within 1000, that is not possible. So you have to study, you have to figure out the questions, you have to answer it. Okay, by doing randomly, maybe you will get a rank in 1 lakh or 2 lakh. Okay, so 1 lakh 1000 or 1 lakh 1001. That can be done using luck, but if you have studied, then definitely you can get a rank below 1000. Now let's move on. The magnetic flux phi b enclosed by the loop PQRS will be QB equals to BA into BLX. So here we have a so we are doing motional electromotive force. Here we have a rail means where the train moves, right? This is a train. This is a train, small train, very thin train, and it is moving towards this. This is a junction, this is a platform. The train is moving towards the junction. So when it is moving towards the junction with the velocity v, okay, and the entire rail is actually suspended over a magnetic field. So when it is happening, what happens is that it produces a magnetic it produces an electromotive force. Okay, the electromotive force, that is a current will produced along this rail in these two junction. You will get a current based on either in this direction or in this direction based on the direction of motion. Okay, you will get either a upward current or a downward current based on the direction of motion. If it is in this direction, you will get one direction. If it is another direction, you will get in the opposite direction. So for this example, when it is moving towards the platform, you will get a current in the downward direction. If it is moving away from the platform, you will get a current in the upward direction. Again, Lenz's law, you can apply and find it out. Anyway, direction is not important over here. So what happens is that when this rail moves towards the junction, the area enclosed in this portion actually decreases. So area decreases means the flux which is linked with the coil, phi is equal to BA, that will also decrease. Okay, and from that decrease you can calculate the induced EMF is given by BVL or BLV. Okay, so this is the expression for induced EMF in a moving rail, and this formula is very important. Let's see one question. A metallic rod of length 1 meter held along east-west direction is allowed to fall down freely. So here we have a so this is east-west direction. East-west direction is not important. So now you are allowing this to fall through the magnetic field. Okay, horizontal magnetic field of Earth, this is called horizontal magnetic field. It is given by 3 into 10 to the power of minus 5. Okay, they might not give you horizontal magnetic field, they might give you the inside a magnetic field, but that is same. Now the EMF induced in the rod after an instant of 2 seconds. Now if you see that nothing is mentioned except the length of the rod is 1 meter. So when you allow it to fall after 2 seconds, what happens is that it gains a velocity. So induced EMF will be obviously BVL. Now V is not mentioned, but it is mentioned it is allowed to fall from the rest, and we are trying to find the EMF induced after t equals to 2 seconds. So we can use the equation of motion to calculate the velocity. So when the object is falling under gravity, the velocity is given by g into t. U is 0, u plus at, u is 0 over here. Gravitational acceleration is the acceleration of the body. So gravitational acceleration is given as 10, time is 2 seconds. So the velocity is 20 meter per second. Okay, so velocity after 2 seconds is 20 meter per second. Now everything is given. So B is 3 into 10 to the power of minus 5, velocity is 20 and L is 1 meter. So you get 6 into 10 to the power of minus 4 volt. Okay, so induced EMF is 6 into 10 to the power of minus 4 volts. Easy question. Okay, don't make things complicated. Only complication you might face what is the velocity. For that, gravitational acceleration is given. That means you have to use the equation of motion. Let's move on to inductance. What is inductance? An electric current can be induced in a coil by flux change produced by another coil in its vicinity, or flux change produced by the same coil. Okay, the flux through a coil is proportional to the current, that is phi b is proportional to I, and you can say that induced EMF is proportional to rate of change of current. So let us understand. We have a coil. We have one coil over here, another coil over here. Now this coil's current I am changing. I am changing the current by changing the rheostat. Okay, by changing the rheostat, we are changing the current that is linked with this coil. They are not moving against each other. Only thing we are doing, we are changing the current through this, and because there is a changing current, the magnetic field will be produced by this coil. So magnetic field is always produced by a coil. Now if you change the current, magnetic field strength will change. Magnetic field strength changing means the field lines which are linked with this bigger coil also changes. So we are changing the current. By changing current, we are changing the magnetic field, and that changing magnetic field is producing an induced EMF in the other coil. Now this can also happen in coils when the coil itself under an changing current produces a magnetic field which opposes its own change. This is also possible. Okay, so one of them is called self-inductance, another is called mutual inductance. Okay, mutual inductance is the let us consider when it is happened between two coils, it is called mutual inductance. So let us consider two long coaxial solenoid S1 and S2, each of length L. When a current I2 is set up through S2, in turn it sets up a magnetic flux through S1. Let us denote it by phi1. So N1 phi1 equals to M12 I2. Here M12 is the mutual inductance of the solenoid S1 with respect to S2. So when you are changing current in one coil, there is a change in flux in the other coil. So you are changing the current, magnetic flux changes. Magnetic flux changes means it induces a current, and the relationship between two coils is actually fixed, and that is called mutual inductance. Now more than mutual inductance, what we are more interested is self-inductance. We'll come to that. Similarly, a current I1 is set up through S1. In turn, it sets up a magnetic flux through S2. So now if you take S1 as primary, and S2 will also give you a current. Okay, so either you change in S2, you get a current in S1. If you change a current in S1, you will get a current in S2 as well. Now in this case, the formula is N2phi2 is equal to M21I1, and fortunately, one very important point, these two mutual inductance is same. So mutual inductance between two coils is actually fixed, and it depends on obviously mu naught, what is inside the coil. So if you put an iron bar, maybe the mutual inductance will be different. So it depends on mu naught, N1, N2, that is number of turns in each coil, area of each coil, and length of the coils. Okay, so this is the general formula of mutual inductance. So the mutual inductance of pair of coils of solenoid etc. depends on their separation as well as their relative orientation. So suppose in the previous case, if you go back to our here, we'll see that they are coaxial. Instead of coaxial, suppose one coil is like this, another coil is like this. So this will also give you a separate mutual inductance, but once it is fixed, the mutual inductance will also be fixed. So it depends on their separation as well as their mutual orientation. Suppose this is a coil, this is another coil, okay, this is a coil, then this is another coil. The mutual inductance between these two coils and these two coils will also be different. It depends on their separation and their orientation as well. Now Faraday's law can be written as epsilon equals to minus di2 by dt. It shows that varying current in a coil can induce EMF in a neighboring coil. The magnitude of the induced EMF depends upon the rate of change of current and mutual inductance of the two coils. Now self-inductance is more important. In the next chapter, alternating current, whatever we are talking about, they are actually self-inductance. Self-inductance means we have a single coil. Okay, the current, suppose we connect this single coil to a AC circuit. So AC circuit is what? AC circuit is a changing current. Every second current direction changes. Current direction changes means also values also changing. So AC current is like this, right? Like a wave. So when the current changes linked with the coil, what happens is that, okay, the coil itself induces, suppose current, this is the primary current I. Coil itself will try to reduce this current by producing a current in the opposite direction. This is the induced current. Okay, and based on the rate of change of current, okay, the induced current value will also change. Okay, and that is why the induced EMF in this particular case is given by minus L di by dt. So rate of change of current is proportional to induced EMF, and this L is called inductance, self-inductance or normal inductance. If nothing is mentioned, only inductance is mentioned, then basically this is self-inductance. This is also called back EMF. The term L is called self-inductance, and the value of self-inductance is mu naught n square A into L. So again, as you can see, inductance depends on the number of turns square, area, and length of the coil as well. So it depends on the geometry of the coil. Work needs to be done against the back EMF in establishing the current. For the current I at an instant in a circuit, the rate of work done is half Li square. This work done is stored as a magnetic potential energy, and thus magnetic potential energy is given by half Li square. So you can say that self-inductance is basically magnetism's response to capacitance. Okay, in capacitance charge is stored, also energy is stored. So inductance or self-inductance is a response of magnetic fields towards the capacitance. Okay, you have a dipole, I also have a dipole. You have a capacitor, I have inductance. Okay, so that is basically everything is related. Electric field has something, you have a positive charge, I have a north pole. You have a negative charge, I have a south pole. Okay, you have a dipole, I have a permanent magnet. Your poles can be separated, my poles cannot be separated. So I am more stable than you. So that is what they are always fighting with each other. So because capacitance is giving energy stored is half CV square. Similar to that, the energy stored in a inductor is half Li square. Solenoid of inductance 2 Henry carries a current of 1 ampere. What is the magnetic energy stored in the solenoid? Very easy. Magnetic energy stored is half Li square. So half into L is 2, I is 1. So energy stored is only 1 joules. So energy stored is only 1 joule. Now AC generator is an application. Another application of mutual inductance is transformers, where current is being changed in one coil and it is basically inducing another current in the secondary coil. So the coil which the current changes is called primary, and from where you collect the induced current is called secondary. Okay, we will study more about transformers in the alternating current chapter. Now AC generator is another example, another application where we basically produce current by rotating a coil through a magnetic field. So if you rotate a coil in a magnetic field, basically what you are doing, you are allowing the change of flux through the coil, and because of the change of flux through the coil, an induced EMF is produced, and this is the source of our all energy. Currently this is the source of our all energy, except solar power stations. Solar power stations are limited, up to 10% of entire global energy is produced from solar. Other than that, 90% of our energy comes from this AC generator. What is the function? So it may be hydroelectric power, it may be coal based electric power, it may be any other form of electric power. Always there is a rotating coil inside a magnetic field. So we say turbine, if you have heard the term turbine. So flow of water is used to rotate a turbine, and then the turbine is producing electric energy. Now what is a turbine? Turbine is basically the blades of this coil. Okay, this is the axle and this end is connected to a turbine. Turbine is the rotating fan. Now when you are allowing the water to flow through that fan, this coil rotates, and based on the strength of the magnetic field and strength of the water that is being produced, what you are getting? You are getting hydroelectric power. And in case of coal, what happens? They boil water, they produce steam, and that steam is basically allowed to pass through the turbine. Okay, and then again the same method, the steam cools down, it transfers energy to the fans, and the fan rotates, and that's how we produce coal energy, coal based or power based energy. Now efficiency of coal based energy are very less, because most of the power is basically converted into steam, and not all energy of the steam can be converted into electrical energy. In that sense, hydroelectric powers are less power consuming, because it does not affect the environment by a huge amount. Yes, there is an environmental implication in hydroelectric power plant as well, but that is far less compared to coal energy based production. Okay, where pollutants are more. Solar energy is something different. We will not discuss that in our PU2. Maybe if you study electronics in future or physics in future, then you might study about it. An AC generator converts mechanical energy into electrical energy. Mechanical energy means the energy of steam, energy of water. The induced EMF for the rotating coil of n number of turns is given by epsilon EMF, same formula. Only thing is that here the rotation is time dependent, so it is basically dependent on cos omega t. So speed, angular speed dependent. Okay, so cos omega t is the angle, cos omega is the angular speed, t is time. So after some time, what will be the induced EMF? So from there we see that induced EMF is given by epsilon naught sine omega t. This is same as an AC voltage. This is same as AC voltage. We use AC in our household, and why we use AC current? There are two major reasons. One is the AC is easier to transmit, and obviously it is easier to produce as well. Direct current that we are getting from our power generation generating stores, this is an AC form. Okay, and that same AC can be transmitted easily without any requirement of converting it into DC. Okay. Here this epsilon naught is the maximum power generated, which is given by NABW or omega, NAB omega or NBA omega. Okay, NBA omega is the maximum power, maximum voltage. You should remember this value as well. Now this is the end of this chapter. Now we will move on to our second chapter, electromagnetic waves, without wasting our time. So displacement current, speed of light and electromagnetic waves, these are the concepts that we'll study in this chapter very quickly. So let us start with displacement current. The total current I is the sum of the conduction current denoted by IC and displacement current denoted by ID. I equals to IC plus ID, and ID is given by epsilon naught d phi E by dt. Now let us understand briefly what is displacement current. Okay, suppose you have a capacitor plate, very simple capacitor plate, parallel plate capacitor. You are charging the capacitor. You are charging the capacitor. Now capacitor plates, they do not have any connection between the plates. So this is the plate. So current which is coming up to here, they have no path to go to the other side and continue the conduction. So if you connect it to a battery, what happens is that you should not get any current in the circuit at all. Okay, be it an AC circuit, be it an DC circuit, the capacitor should not be allowed to pass any current. But in reality we see a current up to as long as the capacitor is charging. When the capacitor is charged, fully charged, it blocks all DC. That is its property, because it has already gained the maximum charge, so it blocks the DC. But generally when it is charging, it cannot block any DC or AC. Why it is so? So that was very puzzling, and we tried to apply Ampere's law in this particular case. We have taken one surface along this, one surface along this. So same surface we have taken two way. We can do that, right? Consider a bottle cap. So bottle of the cap, you can take one surface along the circular side which is open. If you put some paper on that, that will be one surface, and the closed surface side of the cap will also give you the same surface, but the contour is different. It's slightly tricky to understand in terms of geometry. So if you can consider that this is the surface area, right? Now this surface area I can enclose it like this or like this. Both are actually giving you same surface. It does not, you should not think them as different surfaces. Okay, the surface, overall surface, I can either, you can take this one or this one. Okay, surface area or the B dot dl should remain same, right? So either you take the surface from this side or you take the surface from this side. Now when you are going from this side, you are seeing, okay, the current I is basically included in the circuit. So current I is here, and I am saying, okay, current I is here, so mu dot B dot dl should be equals to mu naught I. But when I am going from this side, no current, no physical current is passing through this. So no physical current passing through this means mu dot B dot dl should be 0. So on my left hand side, it's like a limit. Consider this is like a limit. You have all done limit, right? So limit, when you are doing limit, x tends to 0 plus, and limit limit x tends to 0 minus, right? From, if you have a number, you are going from this side or this side, right? That's how you check whether the function is continuous or not, right? So if a function is continuous, then from both sides the limit value should be same. Similarly, when you are approaching the circuit from this side, you are seeing, okay, mu B dot dl is not 0, it is giving me mu naught I. But when you are approaching the same circuit from the left hand this side, what you are getting? You are getting B dot dl equals to 0. So same equation, but you are getting two different results. So B dot dl cannot be a discontinuous function, it is a continuous function, because the value of magnetic field you can measure physically. So B is known, dl is obviously not 0. So one side you are getting B dot dl non-zero, from other side you are getting B dot dl 0, which is completely not acceptable, because B is a physical quantity which can be measured at each and every point. So it does not make any sense, it is a discontinuous function. So what is happening? So Maxwell came into rescue, and he said that actually the current which is conducting through the conductor is called conduction current, and there is an invisible current which is passing through these plates, and he named this current as displacement current and termed it ID. And how this current is basically carried away? So if you consider the plates, there is an electric field inside the plates, and as the capacitor is getting charged, more and more charge it is acquiring, the electric field is also increasing. So electric field between the plate is not constant, but it is increasing. So as the electric field is increasing, okay, the displacement current is flowing. So as long as there is a changing electric field, it will also be able to produce a current. So that is the idea of Maxwell, and he says that current can also be produced by changing electric flux. So here d phi E is the electric flux. In Gauss's law chapter we have studied it. So epsilon naught is the free space permittivity, epsilon naught d phi E by dt. So that derivation is obviously not part of your syllabus. We studied in our graduation when I was studying physics. So that derivation was a very important derivation, how we have to derive this. Anyway, so that is the basics of this displacement current. Now Maxwell's equation, after this Maxwell goes even further and he combined 4 already existing equations, namely this is the form of Gauss's law, this is the form of Gauss's law of magnetism, this is the Faraday's law, and this is basically a form of Faraday's law. Okay, Faraday says epsilon equals to d phi by dt, but epsilon can be calculated as E into dl integration. So this is the Faraday's law, modified Faraday's law, and this is the actually Ampere's Maxwell's law. Okay, Maxwell gave only up to this much. Okay, B dot dl equals to mu naught IC, and this portion is contributed by Maxwell. So this is the Maxwell's contribution. That's why this complete equation is called Ampere's Maxwell's equation. Now when you study all these 4 equations and if you solve them together, you will get a unique solution. You get a unique solution, and that solution leads to something which is called electromagnetic wave. Changing electric field produces changing magnetic field, and thus changing electric field and changing magnetic field together produces electromagnetic wave. Because electric field and magnetic field both are required, that's why they are called electromagnetic wave. And what is electromagnetic wave? All lights that we can see, light, heat in the form of radiation, everything is basically electromagnetic waves. Okay, and without electromagnetic waves, what would happen? We would be blind, because there is no ray, no light to see anything, right? So because of electromagnetic wave we are able to see, and Maxwell actually gave the theory how electromagnetic waves are actually produced. Okay. Now equation of waves, so if you solve those 4 equations, you will get a equation similar to this. Electric field is given by E naught sine kz minus omega t, and By is equal to B naught sine kz minus omega t. Omega t is the angular frequency, k is the wave vector or wave number, z is the direction of propagation of the electromagnetic wave. So if you see that electric field is along x-axis, electric field is along x-axis, okay, magnetic field is along y-axis, then the wave is along z-axis. Okay, so this is the direction of wave. So wave is propagating along z direction. So this is the electric field Ex, this is magnetic field Ey, and this is the wave Em wave, okay, along the z direction. Now how can you find the direction? So you can use right hand rule. If you point your fingers in the direction of electric field, if you point your index finger towards the electric field, if you point your middle finger towards the magnetic field, then your thumb will give the direction of propagation. Okay, so this right hand rule you can remember. Or what you can do, there is one more rule. First point all of your fingers towards electric field, curl your fingers towards the magnetic field, and then the thumb will give the direction of propagation. Okay, thumb will give you the direction of propagation. Now based on this concept, we have seen some questions where they have given you electric field and direction of propagation, then they ask you what is the magnetic field. In that particular case, this rule is much more helpful than this rule. Okay. Here k is related to the wavelength lambda and speed of light by equation k equals to omega by c equals to 2 pi by lambda. So k, omega, c, lambda, they are all related to each other. The wave propagation in this case is direction E cross B, that is z direction. Okay. Also the speed of light or speed of wave, generally light means not only visible light, all sense of light, all the light of electromagnetic spectrum. the speed is E naught by B naught, and in free space, that is when there is no medium, all rays travel with the same speed. Speed of all types of ray is constant, which is 3 into 10 to the power of 8 meter per second. It can be E naught by B naught, it can be Ex by Bx as well, By. So either Ex by By or E naught by B naught, and that value will give you speed of light. Now speed of light itself is a content. The speed of light is given by, if you try to calculate in terms of mu naught and epsilon naught, you will get E naught by 1 by epsilon naught into mu naught for free space. And for free space, if you calculate this value, you will get this as 3 into 10 to the power of 8, approximately, very close, 2.99 something, okay, meter per second, which is exactly as same as the measured value of speed of light. That means the Maxwell's theory is basically saying that, because this value is known for visible light, by the way, okay, other unknown other lights we measured it later on, but this value was known for visible light. So that means the wave that was being talked in Maxwell's equation is basically giving you electromagnetic waves. Okay, so from there actually correlation, when Maxwell solved this equation, it was not clear what wave it was, but when we calculate the speed of the waves, we realize that these are nothing but electromagnetic waves. The ratio of magnitude of electric field and magnetic field of an electromagnetic wave is in the order of, so ratio of electric field by magnetic field is a constant, and that is 3 into 10 to the power of 8. Okay, for any other medium, the medium is not specified, it is for free space. For any other medium, it can be slightly less than that in terms of 3, but 10 to the power of 8 is constant, so we can say that the ratio is actually of the order of 10 to the power of 8. Now let's move on. Electromagnetic spectrum. So if you see electromagnetic spectrum, this is X-ray, gamma ray. We're starting with gamma ray. Now remember, the rays which are at the top have smaller frequency. Frequency is very small. Frequency is very high. High frequency and low wavelength. So wavelength is very small, but frequency is very high. So these rays are generally considered dangerous because they can penetrate any object, especially rays like gamma rays, X-rays, even ultraviolet rays. They can penetrate any object. Okay, gamma ray is basically a treatment for cancerous cells. So if you have a cancer in your body, then gamma rays are sent through the cancerous cell. Cancerous cell, it can penetrate through your skin and go to the cancerous cell. Cancerous cell absorbs the gamma ray and then it gets destroyed. Okay, because it have very low wavelength, you can pinpoint the cancerous cell and you can send the gamma ray therapy. So this is one of the example, but gamma ray therapy or chemotherapy that you may have heard. Chemotherapy also have its drawbacks, because when it is passing through your body, it is also being absorbed by your normal regular healthy cells, and they can also die from this therapy, and your healthy cells also gets weaker. Okay, so gamma rays is one of the treatment of cancers. X-rays are basically the same thing that if you have ever broken a bone, or if you have seen someone has broken their bones, then some X-ray plate is there, which is basically scan of your bones. X-ray can pass through your skin, but it cannot pass through your bones. So bones basically absorbs the X-rays, and you get an image of your bones, right? So where it is broken, where it is not broken, how does it look like without cutting your skin. So this is amazing. Ultraviolet rays are also very useful for signaling purposes. Also, it can be used in your water purifier, okay, where you have heard UV RO. RO is reverse osmosis, and UV is basically treating the water through UV rays. Okay, so treating the water through UV rays kills all the type of germs, and that's how your water becomes sterilized without even boiling it. So without boiling, if you pass something through ultraviolet radiation, then those germs die and you get a fresh water. And similarly it is being used for killing germs before operations. Also, the equipments used in an operation theater, they are being killed off the germs using ultraviolet ray. Visible ray, the ray that we can see. Now if you see the entire spectrum, visible ray is very small. Visible ray is very small compared to the entire spectrum. Now in visible ray, we start with 400 nanometer, violet, blue, blue, green, yellow, orange and red. So red goes around 700 nanometers. So from 400 nanometer till 700 nanometer in terms of wavelength we can see. This is the wavelength. Okay, so this is the only range of our eyes. Beyond that there are a lot of other universe that we generally do not see in our naked eye. Okay, infrared ray is the heat. Basically when you are radiating heat, suppose during the day your body absorbs heat and at night your body radiates that heat. So whatever heat that we radiate, any object, not only us, any object radiate heats in the range of infrared ray, including our earth. Microwaves we use to heat up our food. Short radio waves used for communication purposes. Television and FM radio, television waves generally we use in case of dish antenna, right? You have a dish TV in your home, so that dish actually catching the waves in the form of television ray. FM radio, if you are someone who is listen to FM radio, okay, so that is basically also have a wave in this zone. AM radio is also a type of radio waves which was used to be used in the past. Nowadays AM radio has a very limited application. Long radio waves can be used to transmit a signal from for a very long range. Okay, we use it for our astronomy purposes, and some animals use this to communicate as well. Now let's move on to electromagnetic spectrum. So as I mentioned, these three are in the range where the frequency is higher than our visible light and wavelength is smaller than our visible light. They are all very, very dangerous rays, and all of them are basically absorbed by our ozone layer. So that's why it is very important for us to protect our ozone layer. If these rays are able to penetrate ozone layer and fall on our skin, then no matter how thick sunscreen you apply, your skin will burn out instantly and you will die of burning. Similarly, these rays are below the visible range. They are not that harmful, okay, but infrared ray is responsible for greenhouse effect. If you want to study more about infrared ray, you can go and check that out. Which of the following radiation of electromagnetic waves has the highest wavelength? So if you go along the electromagnetic spectrum chart, lower you are going, higher is the wavelength. So normally radio waves have the highest wavelength. After radio waves, microwaves have the highest wavelength. So correct answer is microwaves. X-ray, UV and infrared, they are all above microwave, so that means they have smaller wavelength. Frequency wise, X-ray has the highest frequency in this given question. UV ray has the second highest frequency. Okay, so now formula sheet, as usual I am giving you formula sheet for both the chapters. So EM wave, so here is the electromagnetic induction formula sheet, here is the AC generator formula sheet. Next we have EM waves. Not too many formulas are there, but equation of wave, the speed of light. So you should remember these formulas. Based on this we can get 1 or 2 questions. Right, this is the end of this lecture. I hope you enjoyed today's session, and if you still have any concern, any questions, please don't forget to mention in the comment. Also I request you again, don't forget to subscribe to our channel and give it a thumbs up if you like this video. I'll be back with a new chapter very soon. Also live is happening very, very soon. Don't forget to join me on live in our channel. Till then, bye.